Hello students, today we are going to start a new chapter, that is analytical chemistry. So in this analytical chemistry, we will study detection of cations and anions, that is the main topic, and along with that we have detection of gases and detection of cations by a reagent and by a platinum wire, using platinum wire. So let us first understand what is the meaning of analytical chemistry. So determination of chemical components is a given in a given sample is called analysis. Determination of the chemical components in a given sample is called analysis. Now in chemistry we have two types of analysis. One is qualitative analysis. See, let us see here, qualitative analysis, and another one is quantitative analysis. So two types of analysis are there. Okay. Analysis means determination, right? So two types of analysis are there. Now quantitative analysis is the qualitative analysis is the analysis which involves the identification of the substance. What we do by this identification of the substance. Right? And in quantitative analysis, which involves the determination of composition of a mixture. So here this will involve determination of the composition of the mixture. Means what are the substance present in the mixture. So determination of the composition of mixture. So these are the two parts in this, qualitative analysis and quantitative analysis. Now when we are talking about qualitative analysis, identification of this unknown substance, let us say identification of the unknown substance. Okay, and here when you are talking about identification of unknown substance, suppose I give you one salt, okay, and I ask you to find out which cation and which anion is there, right? So that is what we will be studying here, qualitative analysis. So first we will be doing this qualitative analysis today, and here it says that identification of unknown substance is done by carrying out a chemical test with the help of reagents. So we need some reagent, something with the help of which we can identify the unknown substance. Now a reagent is a substance that reacts with another substance. So mostly we will see alkalis are the most important. Here we will say alkalis are the most important. Alkalis and acids are usually. So here alkalis are most important laboratory reagents. Right? So we will be using alkalis, right, to here. Now this, when we are talking about when they are added to the certain salt solution, they will give us characteristic precipitate of metal hydroxides, and by that we will able to identify metal ion. So what are we going to do is detection of cations. Detection of cations. Excuse me. Now colors of the salts and their solution. So mostly what happens over here, we have studied in the periodic table, representative elements and transition elements. So when we are talking about representative elements, we have studied in the periodic table that the group 1, group 2, group 13 and group 17. These are all representative elements which are mostly colorless. So I am writing it over here. When we are doing this, now we have studied what? Representative elements. Periodic table have representative elements and transition elements. So representative elements are group the elements which are present in group 1, group 2, group 13 and group 17. So mostly all of group A elements which we are saying, so these are the groups which the elements are known as representative elements and they are mostly colorless, right? Now the another type of the substances are transition elements. Transition elements are the elements which are present in the periodic table from period, or you can say group 3 to 12. So elements present in group 3 to 12 are known as transition elements, and these are mostly colored. So colored substances here. So here if their salts, we can say salts of these elements, okay, are colored, right? So different colored salts have a help in their identification during qualitative analysis, right? So we will do action of alkali on metals, right? And to detect cations. So action of alkalis on metal salt solution we'll say, and we will get the color precipitate, and by that we will able to know which cation is present in the salt. And similarly later on we will do which anion is present in the salt. So detection of cation and detection of anions, once you will understand, you will able to do salt analysis. So when you say salt analysis means, again as I told you, analysis means determination of chemical component of a given sample. So from the sample you will able to identify which is the cation and which is the anion, right? So unknown substance from the unknown substance. Now another important thing is, if the question is there that why are we using alkalis only to detect cations? So we use alkalis because when alkalis are added to salt solution, they impart color precipitate and the solubility also. So by the color precipitate and the solubility in excess of alkali, we can able to identify the cation present in the salt solution, right? So that is what we are going to study. Now let us study detection of cations by alkalis. Now there are two alkalis which we will be using. One, detection of cation with NaOH, right? So we will be using NaOH here, right? So let us say detection of cation with sodium hydroxide solution. Okay, so I'll write NaOH solution. Now before we study this topic, let us understand what is precipitation reaction. Why? Because when you are using NaOH solution and adding it to salt solution, so detection of cations with NaOH solution, here what happens, suppose we are using any substance, say ferrous sulfate. Okay, now we don't know it is ferrous sulfate, it is unknown substance given to you. We want to detect that which cation is present in this. So this should be in aqueous state. Then only ions will be free, and NaOH solution, again you are taking this also in aqueous state. So what happens when you are taking both of them in aqueous state, there their ions will easily get exchanged, or you can say exchange of radicals takes place and two new compounds are formed. So here we will get ferrous hydroxide, which is a precipitate, and we will get sodium sulfate, which is soluble, it is in aqueous state. So this is the rule for precipitation reaction. When we say precipitation reaction, the two reactants must be in soluble state. Aqueous plus aqueous, when these two will combine, you will get one of the insoluble substance, colored precipitate, okay? And by this we will able to identify the cation present in this is ferrous and another one is aqueous. So this is what it is, right? So this is what is the precipitation reaction. When two compounds in their aqueous state react to form one of the insoluble products, one product must be insoluble and which will able to filter and collect the solid part of that. Okay, or you can see the product, this product will be in solid state and this will be removed as filtrate, and this is how we will able to identify. So that is why I explained you precipitation reaction, because all of them will be precipitation reaction. Okay, so all precipitation reaction only we will be studying right now. Now our next we will be I'll be drawing one table. Okay, and in that we will see that here action of sodium hydroxide solution on certain metallic salt solution, right? So here detection of cations by this. Now let us take salt solution. Okay, here cation, I will say. What is the cation in this? So we will come to know that, we will come to know at the end, but let me right now here writing cation. Then what is the salt solution you are taking? That is important. What is the salt solution you are taking? After that, what is the precipitate formed over here? And the color of the precipitate, color of the PPT, right? And whether it is soluble and not soluble in excess. So solubility, okay, solubility in excess of alkali. So this is what we are going to study today, right? And I will be drawing one table and same time I will be writing reactions over here. So first let us take 3 colored salt solution. Okay, so we have in our syllabus the 6 cations. So first we are taking 3 colored salt solution. So the first one we are taking ferrous. Okay, cation is ferrous, but salt solution which we are taking is, you can take ferrous sulfate, ferrous chloride. See, just now I explained you precipitation reaction. So all these salts which are taken should be soluble. Then and then only the reaction will take place. Otherwise, it's not possible to have a reaction. Only will not take place. Exchange of radicals will not take place. So that is what it is. So ferrous sulfate you are taking. So here the first reaction what we are doing is we are taking ferrous sulfate, right? Okay. Now we have to add NaOH. Now let me explain you how you will be doing it. See, when the sodium hydroxide, that is caustic soda also you can say, when sodium hydroxide solution is added drop by drop to the solution of metallic salt, okay, the metal hydroxide formed gets precipitate. Okay, so we will get over here precipitate is ferrous hydroxide. And here see how the reaction is taking place. Ferrous hydroxide, exchange of radicals takes place, Fe and OH, and then the byproduct will be Na2SO4. So this is, here we are getting dirty green. The color of the precipitate is dirty green precipitate. Okay, so as I told you, the color of the precipitate identifies the metal ion. This metal ion will be identified by its color, that is dirty green precipitate, and some precipitate metal hydroxides dissolved in excess of sodium hydroxide solution to give soluble compound. But in this case, what are we doing? See, we have to imagine it this manner. First step over here, what will you do to detect cation? So you take, you will be given one unknown salt. So first thing what you will do is, you will make the solution of this. Prepare ferrous sulfate solution. Now divide the solution in 2 test tubes. Imagine these are the 2 test tubes. So divide the solution in 2 test tubes. Okay. So in equal amount you take, and in both the test tube you have ferrous sulfate solution. Now with one you will be using NaOH and in one you will be using NH4OH. NH4OH alkali, that we will do it later. But when you are adding NaOH, you will be first adding NaOH in little amount. Drop by drop, very slowly, in little you will add. So on adding in little, you are getting dirty green precipitate. This reaction will take place. Now to this same test tube, means to this product, you add excess of NaOH. So on adding excess of NaOH, solubility in excess we will check. So what happens? This dirty green remains dirty green. So I will say this is insoluble in excess of sodium hydroxide. So dirty green precipitate remains dirty green. Okay, so dirty green precipitate is insoluble. That is how you will be writing. Clear all of you? So this is what it is, right? First detection of cation. So first one we did. Now second one is Fe3 plus. Now if you want to do, if you want to detect ferric, so what we will be doing, for you it is all unknown salt. So the salt given to you is ferric chloride, you are not aware. What you will do again, you will prepare salt solution and you will add NaOH. So when you will add NaOH, you will get ferric hydroxide, okay, and NaCl you are getting over here. Byproduct is NaCl, right? So in this is reddish brown precipitate. So what are we getting is ferric hydroxide you will get, and you will get, you know, here reddish brown precipitate, reddish brown PPT. Okay, so I am not writing here PPT. Let us write here reddish brown, reddish brown color you are getting. Okay, so reddish brown precipitate you are getting. This is ferric hydroxide, which is reddish brown in color, by which you will come to know the cation present is ferric, and it is also insoluble in excess. So in the same test tube, if I am adding excess of NaOH, we are breaking here NaOH. So excess of NaOH we will add, it remains insoluble. Now next we are taking is cupric, Cu2 plus, and if we take here copper sulfate solution. So when copper sulfate is taken here, CuSO4, and we add NaOH, what happens is, okay, here we will get cupric hydroxide, which is a pale blue precipitate, and a sodium sulfate as a byproduct you are getting. And now we balance it. Here also, let us balance the reaction. Now here what happens, we are getting what? Cupric hydroxide solution. Sorry, PPT you are getting. Cupric hydroxide precipitate you are getting, which is pale blue in color. And now to this, if you add excess of NaOH, this will remain insoluble only. The precipitate remains blue only. So these are the three colored salt solution which will give you colored PPT. Okay, here dirty green precipitate, reddish brown precipitate, and pale blue precipitate. So, and all three of them are insoluble in this. Now if we take next one is zinc, or you can take lead. Zinc, let us take zinc sulfate only salt solution. So when you add NaOH, you will get zinc hydroxide, which is gelatinous white PPT. Gelatinous white PPT. Now what happens to this gelatinous, it will exactly look like jelly. So gelatinous white precipitate when you are getting over here, and adding excess of NaOH to this white PPT, we will see that it is soluble and forms a clear solution. So clear solution you will get, means you will see that PPT dissolves, forming a clear solution. So here the reaction will be like this. Zinc sulfate when reacts with NaOH, you are getting zinc hydroxide and sodium sulfate. So zinc hydroxide you are getting, that is 2 NaOH here, and that is zinc hydroxide is gelatinous white PPT. Now to this gelatinous white PPT, if every time whenever you are getting PPT we are adding excess, but in first three cases we saw it is insoluble. So when we are adding here excess of NaOH, we will see that we are getting this PPT dissolves, forming sodium zincate, a clear solution. Okay, along with we are getting here water. Okay, so excess of NaOH you are adding and you are getting a clear solution. This is a clear solution. Clear solution of sodium zincate you are getting, a complex soluble salt you are getting. And now 4 hydrogen, so put 2 over here. So what happens when any PPT is soluble in excess, that time you will have one more reaction, and we are getting over here sodium zincate. Now next one is lead, Pb2 plus. So we are taking lead nitrate. Now we are taking nitrate over here because as I told you, we have to take salt solution only for precipitation reaction. So in the case of lead, only and only lead compound if we talk about which is soluble is lead nitrate. So only lead nitrate is soluble among all the lead compounds. So here lead hydroxide is formed, which is chalky white precipitate. Chalky white PPT. Okay, and again in this case also, if we add excess of sodium hydroxide, we will get clear solution, means PPT will dissolve forming a clear solution. So let us write the reaction here. If we are taking lead nitrate, then adding NaOH, we will get lead hydroxide. Okay, and this lead hydroxide is chalky white precipitate, and along with this you are getting nitrate, sodium nitrate as a byproduct, right? Now next what happens over here, you are adding excess of NaOH to this lead hydroxide, you will get sodium plumbate, Na2PbO2 plus water, like this. Again this is a clear solution, you are getting a clear solution of sodium plumbate. So you will see here these two are soluble. Now means there is one reason why these hydroxides, if you look at this, zinc hydroxide again reacts with hydroxide. We know that acid do not react and base do not react. So again here both of them are hydroxides, so they should not react. But why they are reacting? Because both these hydroxides are amphoteric in nature. They have the property to react with base and acid both. So here you will see both of them are amphoteric in nature, and this is the reason why these two are reacting with excess of NaOH. Here I am writing excess of NaOH, okay, and forming a clear solution, right? Now one more we have, that is calcium. In the case of calcium, if you will see, calcium will form milky white precipitate. If we take here calcium chloride, we get here calcium hydroxide on adding sodium hydroxide to it, and we will get milky white precipitate, and which is insoluble in excess, right? And I am writing the reaction here. So calcium chloride, when we add NaOH, we will get calcium hydroxide insoluble, and we are getting here byproduct as NaCl. So this is milky white precipitate over here, and which is insoluble. Now ammonium salts are also there. So if we want to detect ammonium salts, what do? We have to I'll be writing the reaction over here for ammonium salt. Okay, if I will talk about here ammonium salts. Okay, if I want to detect that in the salt ammonium compound is there, then what you have to do is take a salt solution, add NaOH, again this with NaOH. So ammonium chloride or ammonium sulfate, any salt is there of ammonium compound, ammonium salt is there, then we add NaOH. And what will happen when you add this? You will get a salt plus water plus ammonia gas. So we will see that ammonia gas will start forming and it will release. So here a pungent smelling gas ammonia releases, pungent smelling gas. So a pungent smelling gas ammonia releases, and which will we can detect it by when a rod dipped in concentrated HCl is brought near ammonia, dense white fumes of ammonium chloride are seen. So by this we will come to know the salt is of ammonia. So that can also be detected by NaOH. So all these are detected with NaOH. So here what you have to remember is the table, reactions and the observations. Here main part is the observation, so you can remember how to write observation if it is. So when we will say to the salt solution on adding sodium hydroxide in little, if you get dirty green precipitate is formed. Suppose I say if the question is what would you observe when sodium hydroxide is added to ferrous sulfate. So we will say that on adding sodium hydroxide in little to ferrous sulfate, it will form dirty green precipitate, and on adding excess to the dirty green precipitate, the precipitate remains insoluble. Right? So this is how you will be writing observation. Right? And suppose the observation, if it is asked, what would you observe when sodium hydroxide will first added in little and then in excess to zinc sulfate solution. So we will say on adding little sodium hydroxide to zinc sulfate solution, a gelatinous white precipitate is formed. Okay, and on adding excess to sodium hydroxide to the gelatinous white PPT, a PPT dissolves forming a clear solution. So this is how you will be writing, observation. So three things you have to remember. One, first when we do practicals. See here we have practicals also in the syllabus. So how to do practical that. Second is this whole table which have color, solubility and everything. Third is these reactions, and fourth is observation. So all these things we have to do. Now we will do the second part of this detection of cations, that is with ammonium hydroxide solution. Right? So let us do that. So the same way how we did the sodium hydroxide, same way we will be doing it ammonium hydroxide. Right? So on adding in excess and little, what happens that we will see. Now this is with ammonium hydroxide, NH4OH solution. Right? Now we will draw this smaller, okay. So we get space to write the reactions. Cation. Okay, then we have salt solution. Then we have the PPT formed. Color of the PPT. And solubility in excess. Now in this case, if we are taking here detection of cation with ammonium hydroxide solution. So again same way the precipitation reaction takes place. Okay. In this again we will take first three colored salt solution. So first colored salt solution, okay, is ferrous sulfate we are taking. Or you can take ferrous chloride, any soluble salt of iron you will be taking. Now when you are taking this ferrous sulfate, okay, and adding here ferrous sulfate, and we add a little of NH4OH. Now in the beginning I told you we will be taking two test tube. So in the first test tube you are taking NaOH, you are adding NaOH. I told you you make a ferrous sulfate salt solution and then divide the solution into two test tube. In the first test tube you will add a little of NaOH and then excess of NaOH, and two observations we will do. And in the second test tube you will add little of NH4OH and then excess of NH4OH, and another two observations you will do, and after that you will confirm or infer that the salt in the salt the cation present is ferrous. Right? So after doing the observation, so here we are getting ferrous hydroxide, which is again a dirty green precipitate, and ammonium sulfate you will get. Right, this is 2, so put 2 over here. These reactions are not difficult. just exchange of radicals will take place, and you will get uh, you will get precipitate, and you will easily able to write reaction. So here it is dirty green precipitate, and here solubility in excess is insoluble. On adding excess of ammonium hydroxide, it is the PPT remains insoluble, right? Now next is when you are talking about ferrous. So now next is ferric. Ferric, in this we are taking ferric chloride, okay, adding excess of NH4OH. So what happens, we are getting reddish brown precipitate, and we will get here ferric hydroxide and NH4Cl. Now we will balance it. Here this is 3, so put 3 over here. Now both are 3, we put 3 here. So it is balanced. Here if we, what are we taking? Ferric chloride, okay, and we get ferric hydroxide precipitate. Now the color of ferric hydroxide is reddish brown, and it is insoluble, right? So here we are getting reddish brown precipitate which is insoluble in excess, right? So this is how we will be detecting, and after doing both with NaOH and with NH4OH, we will confirm that the cation present in the salt solution is ferric, right? So this is how you will be doing it. Now next is the colored one, cupric. So copper sulfate you are taking, right? So when you are taking copper sulfate salt solution, okay, what happens over here? You will get copper sulfate you are taking and adding little of NH4OH, right? We will get cupric hydroxide which is a pale blue precipitate, and here ammonium sulfate you will get. Now see, in this case when you are performing the experiment or doing practical, then you have to be very careful, and very small amount you will be adding NH4OH to this salt solution. For you it is unknown, and when you will add drop by drop slowly, you will first when you are adding in little amount drop by drop, you will get pale blue precipitate. Now on adding little extra, if you will add little extra, directly you will get inky blue solution. Exactly the inky blue, the color of this ink of this pen is exactly that type of color you will get. PPT will dissolve, this pale blue precipitate will dissolve and forming an inky blue solution. So here I will write this is soluble and forms an inky blue solution, or you can say deep blue solution, inky blue. Inky blue solution is formed. Now why inky blue solution is formed? Now to the same test tube, what we will do is we will be here same test tube, cupric hydroxide, you have taken here NH4OH. So in the same test tube these products are there, you are adding in that excess of NH4OH, and we will get that tetraamine copper sulfate, right? Copper sulfate like this, okay, right? Copper sulfate in this manner, and tetraamine means 4 times ammonia. So you have to remember like this, 4 times ammonia. So tetraamine copper sulfate, let me write it here closer so I can write the byproduct also. So tetraamine copper sulfate I will be getting along with water. So this is tetraamine copper sulfate, which is complex soluble salt. So tetraamine copper sulfate you are getting, right? Now what happens? This will be detected a complex salt solution you are getting, right? Tetraamine copper sulfate, which is inky blue, or you can say deep blue. In some textbooks it is given violet color. Next is zinc. Now if we take zinc sulfate, and here we are getting zinc hydroxide. Now zinc hydroxide is white precipitate, okay, gelatinous white precipitate. So let me write here gelatinous white PPT you are getting. Now gelatinous white PPT. Now this is here soluble, and now this is soluble when you are saying so here again a clear solution you will get. Clear solution. Let us see how the reaction takes place. Zinc sulfate when you are saying. So zinc sulfate when reacts with excess, first we will add little, then we will add excess. So zinc sulfate when we add little of NH4OH, we will get zinc hydroxide which is gelatinous white PPT. Okay, and then ammonium sulfate as a byproduct you are getting. Now again, to the same salt solution, if you will add excess of NH4OH, to the same, here this is white precipitate and here let us balance this. Now zinc hydroxide, along with this we are adding here excess of, these are the two products. Along with this we will add excess of NH4OH. Okay, so what do we get? Let us see. So we will get here tetraamine zinc sulfate. So 4 times ammonia tetraamine zinc sulfate you are getting. Okay, like this. Along with this you are getting 4H2O. So this is the tetraamine zinc sulfate which is a clear solution. Okay, a complex salt solution is formed which is soluble, means soluble complex substance you are getting, right? So what happens, first you are getting gelatinous white PPT, then you have to add excess of NH4OH in that same test tube, and then you will see the PPT dissolves forming a clear solution. It will look like water, whole it will disappear, PPT will disappear immediately. Okay, now next we will do is lead Pb2 plus. So lead nitrate. Again, as I told you in the previous case also, lead nitrate is the only compound of lead which is soluble. So lead nitrate you are taking, you will get lead hydroxide which is chalky white precipitate. Right? Now in this case it is insoluble. Right? Here lead nitrate when reacts with NH4OH, we get lead hydroxide which is a chalky white precipitate along with ammonium nitrate in it. Okay, so you are getting ammonium nitrate and we here balance it. Okay, so this is a chalky white precipitate which is insoluble in excess of ammonium hydroxide. So only one reaction. Wherever we have soluble, there we will have two reactions. So these two together. Okay, like this. Two reactions. If it is insoluble, then it is only one reaction we will have. Now when we are talking about calcium chloride you take. Okay, any salt solution, calcium nitrate you can take, calcium chloride you can take. So here what happens when you add NH4OH? So it will not form any precipitate. No precipitate occurs even with the addition of excess of NH4OH. So this is because the concentration of OH minus ions from the ionization of NH4OH is so low that it cannot form precipitate. Okay, the precipitate. So this is the reason why we cannot have, we are not getting any precipitate with calcium, right? So this is if we are not getting precipitate with here calcium and there we are getting milky white precipitate, then we can confirm that the salt has calcium ion in it, or detection of cation can be done by that way of calcium. So what I am saying, no precipitate is formed. Why the precipitate is not formed? Once again I am repeating, this is because the concentration of hydroxide ions from the ionization of ammonium hydroxide is very low. Okay, and that is why it will not form precipitate. So I am writing over here, no precipitate is formed here. No precipitate, no PPT is formed with calcium. Right, now one more thing I will explain over here. We can write these two reactions in this manner, and one more method is there. If directly if you are adding X's, then how the reaction will form, that is what we will understand. So all of you, we have studied detection of cations with NaOH and detection of cations with NH4OH. In this, if you will see, two salt solutions in this, here copper sulfate and zinc sulfate. So in excess, cupric hydroxide and zinc hydroxide are soluble, and in the previous one we saw zinc hydroxide and lead hydroxides were soluble, right? So in both the cases, what is common is zinc. Zinc hydroxide is soluble in excess of ammonium hydroxide, and in that zinc hydroxide is soluble in excess of NaOH. So in both the cases, zinc hydroxide is soluble. In this, cupric hydroxide is soluble, and in that lead hydroxide is soluble. So that is what we have to remember. Now I will be rubbing the upper part, and I will show you here one more way we can write the reaction. See here, these two reactions are of copper. So if we want to write the reaction in one more way, that is here cupric hydroxide, and if we are adding directly, we are saying ammonium hydroxide in excess if we add. So then what are we getting? Let us say here, so instead of getting tetraamine copper sulfate, we are getting here, you write cupric hydroxide like this. Okay, 2 times here hydroxide. So we write cupric hydroxide like this. Now tetraamine ammonia 4 times. Okay, ammonia 4 times. Write 4 here. So this is tetraamine copper hydroxide. Okay, plus 4H2O. Here. So you can write either this reaction or you can write this reaction, any one reaction out of these two. And in this case also we can have in this manner the reaction, or instead of this we can write one more in this manner, that is zinc hydroxide when you are adding excess of NH4OH, okay, directly, then we will get here tetraamine zinc hydroxide, ammonia here 4 times tetraamine zinc hydroxide plus water. So again here any one reaction you can write down. So this was our detection of cations. Now in this case again, when let us have what is very important, that let us understand. So if it is asked how will you distinguish between let us say how will you distinguish between zinc hydroxide or zinc and lead ions. So that type of question can also come. I told you in the previous case also, see this table where objective type questions, reactions, observations, all this you have to prepare. Okay. Now let us have one more type of question. This type of question can also be asked, distinguish the following pairs by a chemical test. So how will you distinguish? Now the pair is here zinc nitrate and lead nitrate. How will you distinguish these two? Okay, so if you will distinguish by NaOH, by adding NaOH, then both the hydroxides are soluble. You cannot use NaOH over here. So we have to use the reagent NH4OH. So what we will do is, we will say that add NH4OH. So let me write it like this. Here, zinc nitrate, okay, solution you will have, and lead nitrate solution. So if this answer we have to write, then we will say add little of NH4OH solution, okay, on adding, let us say on adding little of NH4OH solution, okay, a gelatinous white precipitate is formed. A gelatinous white precipitate is formed, okay. Now here, on adding little of NH4OH solution, okay, a chalky white precipitate is formed. Now both of them are white precipitate, so you cannot distinguish both of them just by on the basis of this. So we'll say on, then further, then add excess of NH4OH to the precipitate, NH4OH salt solution, NH4OH solution to the precipitate, okay. A PPT dissolves, forming, you know, here you will say then add excess of NH4OH to the precipitate. Precipitate dissolves, forming a clear solution, okay, that is of tetraamine zinc sulfate, right? And here you will say then add excess of NH4OH salt solution, NH4OH solution to the precipitate. The precipitate remains insoluble. The precipitate remains insoluble, right? So here the precipitate is insoluble and here you are getting clear solution. By this you will able to, you know, distinguish that the solution which is here, the substance which is forming clear solution is zinc nitrate, and the substance in this, the PPT remains insoluble, is lead nitrate solution. Okay, so this is how we will distinguish. So this type of question can also be asked from this topic. Okay, further I will be giving you the practice of this type of questions. Thank you, students.